Okay, in section 4.7, number 11, we have this problem, and it tells us to solve and identify all double roots. Well, one of the problems we have with this is we can't even begin to solve it unless we get all the terms on one side and 0 on the other. So here's what I'm going to do. In order to do that, all we need to do is just subtract 4x squared from both sides. Let's move that 4x squared over to the left side with all the other terms. And we always want to put it in order from the biggest exponent down to the smallest exponent. So let me put the minus 4x squared next, and then plus 4x. And on the other side, since we subtracted 4x squared, it adds up to 0. They cancel out, or they add up to 0. Okay. Now, what do? I look here and I see that I've got an x in every term. So remember, I should always take the GCF out first. So let's do that. If I take an x out of the x cubed, I'd have x squared left. Out of the 4x squared, I'd have a minus 4 and an x left, and out of that last term, I'd have 4 left. Okay, so again, what we're doing is we're trying to factor to solve this. And remember, anytime you factor, or if you, even if you're using the quadratic formula, you always move all the terms to one side and have a 0 on the other in order to solve it. That's how we're going to get our roots, or our solutions. All right. So now, this x squared minus 4x plus 4, it breaks down further. What do you multiply to get 4 and add to get negative 4? Let's see. How about negative 2 and negative 2? That would work. Negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. So this factors out into x. Remember, we put an x here and an x here, and then we put the minus 2 and a minus 2. Okay. So we've got it factored. Now, one thing we might notice is we've got 2 of those x minus 2's. So, my next step is to take each factor and set it equal to 0. So I can set x equal to 0. And then I can set x minus 2 equal to 0. But there's no point in me writing down x minus 2 equals 0 again, though I could, because that occurs twice. And why write it down twice? One of my solutions right here is x equals 0. The other one, if I solve for x for this x minus 2 equals 0, I could add 2 to both sides. And I could get x equal 2. But wouldn't I get that as a solution 2 times? Because there's that factor once, and there it is another time. So this x equal 2 is a solution 2 times, because it had 2 different identical factors that would give me x equal 2. So this is what they call the double root. It means that x equal 2 is a solution twice. Some books say that's a multiplicity of 2. If you have an answer that occurs more than once, you just look at the exponent and say, oh, because I could have written this as x times x minus 2 squared, couldn't I? So I could say that that root of 2 has a multiplicity of 2, or in this book they say it has a double root. So that's what the solution to 11 would be, is these 2 roots here. Okay, on number 13, we need to do something similar to what we did in number 11. We want all the terms on one side and 0 on the other side, so that we can either factor it or possibly use a quadratic formula if we had to. And in this section, we're mostly factoring. So let's move all the terms to one side. I'm going to move them all over to the left side because I want a positive square term. It's hard to factor a negative square term. So I'm going to move the minus 4r over here by subtracting it from both sides. Remember, you can always draw a line straight down through the equal sign if it helps you to make sure that you do it to both sides. Because if you do it to one side, you've got to do it to the other side to keep the equation equal. Well, I have a minus 1, so I could add it to both sides. Okay, it's a plus 1, kind of hard to read. Now this would add up to 0, and that would add up to 0, so I've got 0 on this side. And then over here I have 3r squared minus 4r plus 1. Remember, you cannot squish those terms together. They are not like terms. All right. Now, I can try to factor this. I'm going to do this one a little differently than I've done a lot of the ones in the previous sections. I'm going to use guess and check on this one, and here's why. I've got a lot of prime numbers here. For instance, 3r squared, right here. I'm trying to get it to show up, and it's not. Right there. There's only one way to get 3r squared. You need a 3r and an r. And if you look here at this 1, there's only a one way to get, well, there's 2 ways to get 1. It could be a plus 1 and a plus 1, or a minus 1 and a minus 1. Now, I got to figure out what the signs are. I got to have this work out so that I get a minus 4r. Since I see a minus there, I am pretty sure this is going to be a minus and a minus, because a negative 1 times a negative 1 would give me this positive 1. And then let's check for that middle term. Negative 1r And this would be negative 3r, and that would add up to negative 4r, which is what I want. So to factor this, I've actually factored it correctly using guess and check. And using guess and check, you say, okay, I know the first two places in the first two parentheses give me the 3r squared, and these last two give me this plus 1 here, the number on the end, and you just try to make the middle term work out, with signs. This one was easy because it was all prime numbers. That's why I didn't go to the trouble of doing the splitting the middle term. All right, so my factors are 3r minus 1 and r minus 1. And if I'm solving and I have two things multiplied equal to 0, I know one of the things has to be 0 in order to get 0 when I multiply. So that's called the zero product property, remember? So we see 3r minus 1 is equal to 0 will give me one solution, and another solution would be r minus 1 equals 0. Let me do this second one first because it's really easy. R minus 1 equals 0, just add 1 to both sides. One solution is r equal 1. And then over here, if I solve for r, I can add 1 to both sides. And I get 3r is equal to 1. And if I want to get r by itself to find out what it is, I could divide both sides by 3. And I get r equals a third. So what are my solutions or my roots? Let me remind you, these are solutions. They're also called roots, and these are our x-intercepts on our graph. If we were to go graph this would be a parabola, and it would have x-intercepts that are these two numbers, a third and 1. This is just a list of answers. Remember, it's not a point. It's a list of answers. So these are called zeros as well. So we can call them solutions. We can call them answers. We can call them roots. Totally misspelled that. Roots. We can call them zeros because they are our x-intercepts. Okay, so by now what you've kind of seen in these problems that we've worked here on this video is that all of them had to have terms that had to be moved to one side and have 0 on the other side in order to solve them. Same thing's going to happen in this one and in any of them that have something on both sides of the equations other than 0. Okay, so in order to get this one, I'm going to go ahead and distribute first. Okay, I'm going to say that 6x and 6 times 12 is 72 is equal to x squared. Now I want a positive x squared term, so I'm just going to move these to the other side. I'm going to subtract 6x to move it over and subtract 72 to move it over. And these are going to add up to 0, right, because they both all cancel out. So I'll have 0 equal x squared minus 6x minus 72. And I don't know about you, I just like seeing it on the left-hand side, so I'm just going to switch the sides here. Okay. Now, I got to factor this if I'm going to solve it. If it wouldn't factor, I could use the quadratic formula, but that we've seen that takes a lot of time. So what I'm trying to do, I'm trying to find two numbers that multiply to give me negative 72, and at the same time, those same two numbers have to add to give me this number negative 6 in the middle. Okay, 12 times 6 is 72, okay? And I know that 12 and 6, if I put a minus 6 here, 12 times negative 6 would be negative 72, and 12 plus negative 6, ooh, that's not right. It would give me a positive 6. So let me make this a positive 6 and this a minus 12. Negative 12 times 6 is still negative 72, but if you add them together, then you get negative 6. So how do I factor it? I say, well, one of my factors is this x minus 12, and the other one is this x plus 6. I take those two numbers. Now, those are my factors, but in order to find my solutions, I say I'm going to use the zero product property. I have two things that multiply to give me 0, so one of the two things has to be 0. So I take each factor and say, well, maybe it was this factor that was 0, or maybe it was the other factor that was 0, and it's going to give me my two answers. Remember, I know that I'm going to probably have two answers because there's a square in the problem, and that exponent tells me about how many roots to expect. So if I want to solve the first little equation there, I could add 12 to both sides. And I get one solution, or root, or x-intercept, or 0 is x equal 12. And the other one, if I subtract 6 from both sides, I get x equal minus 6. So usually what we do is we list them from smallest to greatest in these little set brackets. You do that and then you'd circle it. You could also circle these. That's another way of saying your answer. You could say, but you'd have to circle both of them because there's two answers. 21 is another similar one to this one, but it looks, they just keep getting more bizarre looking, right? as we go here. Y minus 4 squared is equal to 2y. Well, in order to solve this, I'm hoping that I can factor it and set my factors equal to 0. But right now, they have really made me have to do a lot of work here. I'm going to have to simplify all this and move all the terms to one side and have 0 on the other side if I want to try to factor this. So if I want to simplify it, remember this y minus 4 squared really means that I have y minus 4 times y minus 4 on the left-hand side. And I'm just going to copy my 2y down here. In order to simplify this, I'm going to have to multiply this out because y times y is y squared. Y times negative 4 is a negative 4y, and here's another negative 4y when I multiply this negative 4 times this y, and negative 4 times negative 4 is positive 16. All right, well, I can on the left-hand side, I can add minus 4y and minus 4y together. That gives me minus 8y plus 16 is equal to 2y. Now, all the terms are not on one side, so let's get them there now since we finally got that left-hand side simplified. Let me subtract the 2y from both sides. This will give me my 0 that I want on one side. That's why I did it. I wanted to move everything to the other side and have 0 on the right side. If I add all this together, it's y squared minus 10y plus 16. And so I'm looking for two numbers that multiply to give me 16 and add to give me negative 10. Well, 8 times 2 is 16. What if I did a negative 8 times a negative 2? That would still be a 16. But if I add those together, that would give me negative 10. So these were the numbers I was looking for. So I'm going to factor this as y minus 8 times y minus 2 is equal to 0. Those are my factors. But I set my factors equal to 0 to find the solutions or to find the roots or the x-intercepts, whatever I want to call them, the zeros. So we take the first factor, y minus 8 equals 0, and then you take the second one, y minus 2 equals 0, and I have to solve both of these little equations. Well, that's easy to do. Right, we add 8 to both sides on this one, and we get y equals 8 as one solution. And then over here we add 2 to both sides and we get y equal 2. So my solutions are 2 and 8. We always write them in the set brackets, smallest to greatest solution. And there are no double roots here, so don't have to worry about that.